Hello there everybody, this is Mafingie here, and welcome to a proof of concept video for a calculator in Minecraft. So, first, the backstory behind this project. There's all the redstone behind there. There have been many calculators made in Minecraft before, and before command blocks they used to be massive, large, incredibly big things that were a pain to use and a pain to make. But since command blocks, they have become a lot more compact, and this is my own version of the design. It's probably not as compact as it could be, but considering that all you need to actually perform the calculations is this little bit of redstone here, and even that could be better designed and more compact. And this all this does is the display, really. Most of this display here and all the buttons here. So the backstory behind this, I was going to build an 8-bit computer in real life, and I thought, why ever not is this possible in Minecraft? So I started building an 8-bit computer in Minecraft, and I was thinking this is going to be amazing once it's finished. Unfortunately, it would never get finished, mostly because of how complex it would be to do, and I don't know half of how you would manage to work. I am almost certain that it is possible, but I am just not skilled enough to make it work. So, following on from my logic gates video that I released, I started creating the basic unit for computer memory and computer processing in Minecraft, and this is a JK flip-flop. So it is a... okay, how do I explain this? How do I do this? It's a rising edge triggered memory cell. So this bit here would be attached to a clock, and on the rising edge of the clock, basically when it's powered, it will accept input. So if J is on, it's a set reset latch. So this is set, this top wire is on, and obviously nothing happens now that it's set. Then we can reset it like that, and there are some bugs with it at the moment. This is a problem that I believe computers suffer from as well. Where basically a memory latch just cycles. So that's set, that's reset, and if we trigger both, it resets it to the original. Basically it resets itself to however it would be originally, which is this. So I compacted the design quite a bit. This is the most compact that I have managed to make it. This is a clock. There's J and K. There are your two outputs. There's Q and Q underscore, or it should be Q inverted really, but that's as best I could do. So then I started this here. This is, I don't remember what. Oh, this is a clock circuit. This was me trying to create a binary addition or thing circuit. So there's carry in, carry out. That's the output, the sum, and then these are the two binary. This is the input. Basically, these two lines, binary input. It works, but obviously you have to make a pulse lengthener that pulses through this in binary, which is complicated. Then this is where it all started to go awry. This is a clock. This is a modulo 10 counter. Basically, it's a binary to decimal converter. It uses a bunch of those JK flip-flops chained together, and this is the binary decimal converter, which is not very good really. The one problem with this is that it doesn't work. It counts 1, 2, 3, 6. Sorry, 1, 2, 3, 7, 6, 7, 7, and it likes to do this random pulsing thing. Oddly enough, I'm not sure why, but if you're just a bit out of range, it doesn't work. If you go just fly away a bit, there it stops. But if I fly closer, it will begin again. It's very, very strange. But that was the end of my computer making in Minecraft. So I decided just to make a calculator using command blocks, using Minecraft, the tools given to me in Minecraft. So obviously people have done this before. I'm not the first. I don't pretend to be the first. This was just a fun project, and I will release this in a world. This is the display that I'm going to use for that world that I'm going to release. I'll just clip this on top of that and make it look sort of like a normal calculator. But now, let's actually operate the calculator. It can do addition, subtraction, multiplication, and division. So, addition, let's do 2 plus 2 plus, and then 5, I guess. 2 plus 5 should equal 7, equals 7. There we go. And then I'm going to clear the display. I can make it auto-clear, I just haven't bothered to do that at the moment. Let's do 61 minus 85. It should do negatives. I haven't actually tried that before. Negative 24, there we go. Fantastic. So it all works. Now let's try some multiplication. So 6 times 7, times first, times 7 equals 42. Brilliant. Reset again. Now, it doesn't do division remainder. I can get it to do that, and I probably will when I actually release this, because with the scoreboard operation command, you can do addition, subtraction, multiplication, division, and modular division, which will give you the remainder, which is what I want. You can also do some other things. You can do more than, less than. You can swap scoreboard objectives, which is probably the most useful one I found so far. I use that in there to get turn variable 2 into answer, if you have a look on the scoreboard. So the final one, division, 6 divided by 3 equals... Oh, oops. I just set that to plus. Okay, let's set that to divide again. Now the problem with doing that, pressing buttons in the wrong order, is it resets this here. But it still should work. 2. Yep, there we go. And we can reset the whole thing. So, that's just a proof of concept, as I've said. There's the nice display behind. Well, I guess that's a wrap. So, thank you guys for watching, and hopefully I shall see you again soon.